Continuing with the Unit 4 review, number 7. So now we're going to get into doing our substitution and elimination here. So looking at number 7, I have a variable by itself. So this is set up pretty nice for substitution. So I'm going to plug that in right there. So I'm going to say negative x plus 2x plus 4 equals 2. Combine like terms. Subtract 4 to both sides. Okay. So there you go. I got one of the variables. Now I go back and solve for that one. I'm going to plug in. Okay. And we're going to answer this as a coordinate point. Negative 2, 0. Okay. Looking at number 8, this one is set up pretty good for elimination. So I'm going to go ahead and decide which variable I want to eliminate. It doesn't really matter here, so I'm going to go ahead and get rid of the x's here. So I got a positive 2, and I want to turn it into a 4. Okay, but I want it to be an opposite of that, so I actually want it to be negative 4. So I'm going to take this top equation and I'm going to multiply both sides by negative 2. And doing the distributive property, so I'm going to say, I'll write it over here, negative 4x minus 6y equals 2. 4x plus 6y equals 5. Now I'll go ahead and add. And if you look, I get 0 equals 7. Okay, so all my variables went away, so I got a little bit of an issue. So there isn't going to be one solution. This is a false statement. 7 does not equal 0. So this is going to be no solution. Okay. Which what that means is the lines do not cross. All right, number 9. So this one, I got to do a little messing with it here. I'm going to take the top. I'm going to go and do substitution. But I got to get this y by itself, so I'm going to write this over here to give myself a little bit of room to work. Divide everything by 2, and y equals 3x minus 2. Okay, so I got the y by itself. So I'm going to kind of put a box that I'm using these two, so you don't want to actually plug into the wrong equation. So I found out what y, so I'm going to plug in right there for that y using substitution, and I'm going to kind of give myself some room here, and I'm going to say 9x minus 3 times the quantity 3x minus 2. Okay, so I'm only replacing for the y, so the negative 3x is still there, and it is negative, so I'm going to distribute a negative number. And then that's going to be positive 6. Sorry, this is a 3 right here. Oops, sorry. That's a 3, so this is going to be a negative 9. Alright, sorry, positive 9. Positive 9. Alright. So these are going to cross out, and I get 9 equals 9. Okay, so now, same thing happened up here in terms of all the variables went away, but 9 does equal 9, and that actually means they're the same line. So that means they cross everywhere, and that's infinitely many solutions. All right. So now we're going to solve by graphing here. Okay. So we got to go. There's, we could solve by using y-intercepts. We can solve doing different stuff. I'm going to go ahead and put both these into slope-intercept form, where y equals mx plus b. Shouldn't be too much work. So I'm going to start with this bottom one and get this y by itself. So I get 4 minus x equals y. And if it does help, I'll go ahead and just put these on opposite sides and put the x first. Okay. I'm going to put a box around that. So that's one that I'm going to graph. Now I got to mess with this top one and get y by itself. Okay. Subtract 2x to both sides. Divide everything by 2. And I get y equals negative x plus 2. Okay. So I'm going to go ahead and graph these. I'm going to grab myself a straight edge. And so I'll graph this one first. Start at positive 4. 1, 2, 3, 4. And I'm going to go down 1 to the right 1. Same thing here. Start from 2, down 1. And if you look, you could probably, hopefully you could tell by looking at the equations, but they have the same slopes, meaning the lines are parallel, meaning they do not cross, thus they do not have a solution. Okay? So if they're parallel, they don't cross, there is no answer. All right, let's continue solving. So we get to choose substitution or elimination. Most of these are going to work pretty good with elimination, but looking at this first one, this is already set up. I have a set of opposites right there, so I'm just going to go ahead and do that. Those go away. Now I get 5x equals 5. Divide both sides by 5, and x equals 1. Now it's only part of the solution, right? Now I got to go back and plug in. I'm going to plug into this bottom one. It doesn't matter which one. Be careful you plug into the right variable, because I did solve for x. That's just a 2, and y equals 2. So the answer to that one is 1, 2. Number 12, this fraction I got to get rid of. Okay, so what I'm going to go ahead and do is, okay, look at the denominators and find their least common multiple. So basically, what do they both turn into? So like 3, 6, 9, 12, and then 4, 8, 12, 16, and they both turn into a 12. Okay, so that's the number I want to multiply by to clear the fraction out. So I'm going to go ahead and do that. Okay, multiply both sides by 12, and you can think of it, sorry, there's kind of a glare there, as multiplying by 12, over 1. So we are looking at 36 over 4x plus 24 over 3y, and then 8 times 12 is 96. Okay. And then I reduce these fractions. Now if I multiply it by an LCD, common denominator, they should reduce out. So 9x plus 8y equals 96. Okay. And then I'm going to bring this equation back down. Okay. And I will go ahead and clear the fraction. Get some opposites. So I'm going to multiply this bottom one by, sorry, that's parentheses, by -1. I'm going to make my x's cross out. So I'm kind of running out of room here. But I'm going to go ahead and say, rewrite this top one. Okay. And then this one I get -9x minus 8y equals -8. And if you see here, these cross out. So kind of coming up here, I'm going to get 0. Right? 0 equals what, 88? Okay, and that is not an answer with a variable in it, right? So this is no solution because those don't equal each other. Okay. No solution. All right, look at number 13.